So the global temperature change, the observed temperature change, can be split up into components. Okay, you can identify the individual parts that make up the signal. I'll show you a little example here. Okay, so one signal is the global warming trend. Okay, global warming trend shown here in the top graph, just a gradual increase of the temperature. Okay, that is your signal 1. However, your signal 2 is there are variations of the sea surface temperature associated with ocean variability. In some years, in particular the Pacific Ocean, okay, it's a little bit warmer. In other years, a little bit colder. And we know this as ENSO events, and on longer time scales as the Pacific decadal oscillation. Okay, just imagine that your global temperature signal has variations which are shown here. Signal 2, sometimes a little bit warmer, sometimes a little bit colder. Sort of like an oscillation, okay? So now have a look at the combined signal. Just 1 plus 2. And you can do something like this just with an Excel. You calculate a trend, you calculate a little sinusoidal oscillation, and you just put them together. Okay, and let's see what you see in the signal. The green curve is the combined signal, and you can see that over time you get times where you have slowdowns, where the temperature doesn't change. Here's one, and here's one. And during this time, this always will be people coming and say, it has stopped. Hey, look at the signal, it has stopped. Okay. So, on the other hand, you have a transition period where you have very strong changes. Okay, you have an acceleration, and that's when the climate scientists probably come and say, hey, it's an acceleration, it's getting much worse. Okay, so and this is you always have these transitions. Okay? And this explains these so-called slowdowns. Okay, so for example, what you can do is just add some of the more recent data. Okay, and let's see what happened actually to this warming slowdown. Has it continued, or has it gotten worse again? Just have a look at on the next slide. Here it is. I just moved my head a little bit. Difference from average temperature anomalies, and you can see the slowdown in 2000, 2010, and then you get the steep change following after that. And this is one of the steepest changes that we always that we ever observed, this steep temperature. So hooray, here we are. We know a little bit more, okay, about these warming slowdowns and accelerations. Let's have another look at it. Okay, there's a publication that explicitly focused at these warming slowdowns and also the accelerations.